The cosmos is a tapestry woven with visible light and unseen forces. Dominating this unseen realm is dark matter, an enigmatic substance accounting for approximately 27% of the universe's mass energy density. Its presence is inferred solely through gravitational interactions, shaping galaxies and clusters into their colossal structures. This pervasive, non-luminous material represents one of the universe's most profound mysteries. What if its nature is not purely fundamental particle physics, but rather the cosmic residue of advanced civilizations that have transcended or expired, leaving behind a vast, dark legacy? Standard cosmological models posit dark matter as cold, non-baryonic particles that do not interact with light. They exert gravity, pulling structures together, yet remain invisible to all forms of electromagnetic radiation. This fundamental property underpins its cosmic influence and observational elusiveness. Consider the theoretical infrastructure required for a civilization to become dark matter. It implies a mastery over the fundamental forces perhaps capable of converting ordinary baryonic matter into a stable, weakly interacting form or engineering structures that mimic its gravitational signature. Such a transformation would not be a simple decay. It would necessitate an intentional monumental act of cosmic engineering or a catastrophic event on a universal scale, consistently producing these dark remnants across galactic histories. The energy requirements would be staggering beyond current comprehension. If dark matter were the collective graveyard of 1 trillion civilizations, its uniform distribution and consistent properties across the universe would suggest a common evolutionary endpoint or a universal technological trajectory. This uniformity challenges the notion of diverse, independent species. The sheer quantity of dark matter implies that a vast number of these hypothetical civilizations would have existed. Each would have contributed to this cosmic substrate, their presence detectable only through the distortion of space-time, a silent testament to their existence and eventual transition. The mechanism for such a transformation remains hypothetical. Perhaps it involves manipulating fundamental forces to shift matter into a higher dimensional state, or achieving a quantum phase transition that renders baryonic particles effectively invisible and non-interacting with photons. The power of this cosmic graveyard system would necessitate immense energetic capabilities. Civilizations would need to harness stellar energies or even galactic core power to initiate such a universal-scale process. The conversion itself might be a survival strategy, an ultimate form of hibernation or transcendence. Consider the system of interaction. If these entities still retain a form of consciousness or information, it would exist outside the normal parameters of space-time. Their communication might involve gravitational waves or quantum entanglement, operating on scales imperceptible to conventional astrophysical tools. The uniform distribution of dark matter across galactic halos suggests a natural, perhaps inevitable, endpoint for highly advanced life. This could imply a great filter at the technological peak, where civilizations either self-destruct or transcend into this weakly interacting dark state. Their life support system would be the universe itself, their existence sustained by the very fabric of space-time, without the need for energy input in our conventional understanding. They would simply be a stable, gravimetrically influential presence across eons. Such a system would contrast sharply with known biological and technological limits. Terrestrial life requires specific temperature ranges, atmospheric compositions, and energy sources. These dark matter entities, however, would operate beyond these constraints, existing in the deep cosmic void. The resilience of dark matter, resisting decay or interaction over billions of years, speaks to the stability of this hypothetical transformed state. Unlike stars that burn out or planets that erode, these graveyards would endure as fundamental components of the universe's scaffolding. Compared to the fleeting existence of even the longest-lived stars, these dark remnants would represent an almost eternal form of being. Their gravitational influence, a steady, unchanging force, dictates the fate of galaxies, a silent, powerful legacy. However, the primary challenge to this theory lies in dark matter's remarkable uniformity. If it were composed of diverse civilizations, one would expect a spectrum of signatures or varying properties reflecting different technological paths and biological origins. The collapse of this hypothesis begins with the lack of any observable interaction beyond gravity. Civilizations, even in decline or transcendence, are likely to leave some form of electromagnetic neutrino or cosmic ray emission. Dark matter offers none. The sheer energetic cost of transforming baryonic matter into a stable, weakly interacting dark form for a vast number of civilizations represents an insurmountable barrier. Such a process would likely violate known laws of energy conservation or particle physics on a cosmic scale. Furthermore, precise cosmological observations, such as the cosmic microwave background and galaxy cluster dynamics, are exquisitely modeled by fundamental dark matter particles, not by an accumulation of engineered remnants. The fit is too precise for a complex biological origin. The absence of intermediate states also challenges the theory. There is no evidence of civilizations gradually becoming dark matter, no transitional objects or partial transformations. The transition would need to be instantaneous and universally adopted. If dark matter represents a galactic graveyard, it implies a universal fate, a collective demise or transcendence that erases individuality. This contrasts with the presumed diversity of life and technological progression, suggesting a convergent but somber end. The information content of these presumed civilizations would also be lost. Even if they exist as a dark matter state, the intricate data of their histories, cultures, and knowledge would seemingly dissipate, leaving only gravitational influence as their silent epitaph. Existing dark matter detection experiments, designed to observe weakly interacting massive particles, WIMPs, search for specific signatures of particle collisions. These experiments have yet to yield conclusive results, but their methodology is based on particle physics, not complex structures. If dark matter were sentient or a repository of ancient consciousness, it would contradict the fundamental understanding that consciousness arises from complex, interactive neurological structures. A uniform, non-interacting particle field is an unsuitable substrate for intelligence as we comprehend it. The consistency of dark matter's behavior across diverse environments, from dwarf galaxies to colossal clusters, argues against a biological or engineered origin. Civilizations, even in transcendence, would likely introduce variations or anisotropies reflective of their unique development. The current favored hypothesis for dark matter involves exotic particles that arose in the early universe, predating the formation of stars and galaxies, let alone complex life. This cosmological timeline renders the civilization graveyard theory chronologically incompatible. Ultimately, the elegant simplicity of dark matter as a fundamental particle, even if currently undetected, provides a more parsimonious explanation for its observed properties than the monumental complexity required for it to be the remnants of advanced civilizations. The universe is governed by physical laws that dictate structure and interaction. While speculative, the concept of civilizations becoming dark matter pushes against these established boundaries without compelling empirical evidence to support such a profound redefinition of matter itself. The collapse of this theory is not a final dismissal of life's potential, but rather a reaffirmation of the universe's fundamental composition. Dark matter remains a cosmic enigma, but its nature is likely rooted in the laws of physics, not the aspirations or failures of life. The scientific method prioritizes the simplest explanation that fits all observable data. Dark matter, as a fundamental particle, offers a more direct and less convoluted explanation for gravitational anomalies than the highly complex, multi-stage evolution of countless civilizations. Any technology or biological structure, even in a transformed state, would likely possess internal complexity or structural signatures. Yet, dark matter's gravitational influence appears smooth, homogeneous, and without the characteristic clumpiness or patterns expected from such an origin. The very existence of galaxies and galaxy clusters is predicated upon a smooth, early distribution of dark matter acting as a gravitational scaffold. An origin from late-stage civilizations would contradict this fundamental premise of cosmic structure formation. While the imaginative narrative of a cosmic graveyard appeals to human wonder, it remains fundamentally inconsistent with the observed behavior and inferred properties of dark matter. The universe's mechanisms often transcend anthropocentric interpretations. Gravitational lensing observations, mapping the distribution of dark matter, reveal smooth halos surrounding galaxies. These patterns are consistent with vast clouds of elementary particles, not a dispersed collection of highly structured, though inert, remnants. Ultimately, the universe presents mysteries that often defy immediate human understanding. Dark matter's true identity lies at the forefront of astrophysics, compelling humanity to push the boundaries of particle physics and cosmological observation. The silence of the cosmos, devoid of direct interaction from dark matter, forces a reflection on scale. The mechanisms at play are grander, more ancient, and far more pervasive than the fleeting lifespan of any single civilization, however advanced. The idea that dark matter might be a graveyard is a captivating narrative, reflecting humanity's introspection on life's ultimate purpose and cosmic legacy. However, the observable universe consistently points towards a simpler, more fundamental origin for this cosmic scaffold. The pursuit of dark matter's true nature continues, driven by advanced detectors probing the deepest corners of space and the subatomic realm. These experiments seek definitive evidence of particle interactions, not the faint whispers of ancient civilizations. The universe is replete with wonders, both visible and invisible. Dark matter's influence, though profound, appears to be an intrinsic property of the cosmos, a silent, pervasive force guiding galactic evolution rather than a memorial to vanished life. It is in the rigorous examination of physical laws and the empirical pursuit of data that the universe's true narrative unfolds. Fantastical theories, while inspiring, must eventually yield to the compelling evidence gleaned from observation and experimentation. The vast unseen structures of dark matter continue to shape the cosmos, a testament to fundamental forces. While the dream of ancient intelligence permeating the universe remains, the reality of its gravitational presence beckons a deeper inquiry into the very building blocks of existence. What other fundamental cosmic components might hold the silent tales of the universe's origins?